Good morning, everyone. This is lecture number 11, and we are still in motion in 1D. But the good part is we are in the last part of this motion in 1D, and we will be starting and doing graphs in this class and the next class. So that by the next class, we will be done with probably the chapter that takes the longest time to finish, because I don't know, it is like that. Maybe as we go forward, we will be taking lesser time and probably we'll be studying a lot more than what we have done in this class. Graphs. Anyone understands graphs? Yes or no? Okay, I will just quickly go through some basic things about graph, and then probably we will start with question and answer and seeing what type of graph can be made. Let us first talk about what do we understand by graphs. When I say the word graphs, what comes to your mind? Tell me what comes to your mind when I say the word graph. Yes. Tell me till I then figure out. How I'm supposed to make this, because I'm finding it really hard. Okay, I finally succeed in drawing it. Things that look very simple may be really complicated. To draw this, I had to put in a lot of hard work. Okay, what do you mean by graph? Every graph that you see, it has an x-axis and a y-axis, yes or no? This x-axis is known as the independent variable. Why it is known as the independent variable? Because I can give it whatever value I feel like, 0, 1, 2. This is known as the dependent variable. For example, to understand what is this independent variable and what is this dependent variable, if I give you y is equal to 2x plus 3, you must have seen this equation. This is the equation of a straight line. Do we understand this? This is the equation of a straight line. If I tell you to draw the graph, what will you do? You will put the value of x as 0, 1, 2, 3, 4, find the value of y and draw the graph. Yes or no? So you can give any values of x and you can find the value of y. So x becomes your independent variable and y becomes your dependent variable. Got this? So I can write this equation like this. Y is a function of x. Do we understand this? Y is a function of x. So y becomes my dependent thing and my x becomes my independent thing. Clear? Yes or no? Now, if I have the equation like this equation is in the form of y is equal to mx plus c. I hope you know this. Y is equal to mx plus c. This is the equation of a straight line. Do we know this? This is the equation of a straight line. The equation of this straight line, in this equation, this m comes. This m is known as the slope of the equation. Do we know this? This m is known as the slope of the equation. Do we know this? For a straight line, this slope is constant. Do we also know this? For a straight line, this slope is constant. Now, what does this slope tell us? This slope tells us how steep is the line. It is a straight line. How steep is the line? If, for example, I have a line which is straight away like this. This line, as you can see, is parallel to x-axis. Yes or no? The slope of this line happens to be 0. Do we understand this? It is a horizontal line. A horizontal line has slope 0. You can understand it in terms of a hill and a plane. If I am going up a hill, the line is like this. If I am on a plane or flat surface, the line is like this. So horizontal line means slope is 0. Do we understand this? Now the equation of this line will be written in this form. The y ka value will be constant. So if y is constant, this m becomes 0, this m becomes 0, and your equation of line is y is equal to, so this is the line with 0 slope. Do we understand this? Yes or no? Okay. Now, I can also draw a line which looks very ridiculous, but I will still draw it. I can also draw a line which is like this. You can also draw a line which is like this. Now this line is parallel to y-axis. Do we understand this? We call this line as having infinite slope, or instead of infinite, I can call it undefined slope. The slope cannot be found out. The equation of this line will be x is equal to c. X is a constant. X does not change, but y keeps on changing. Do we understand this? X does not change. X is same, as you can see, but y keeps on changing. Do we understand this? So these are the first two slopes. The first one is a zero slope line. The second one is a constant slope line. Anyone understands this? Okay. These are two extremities, but we may not have extremities. I can have a line like this. I can have a line like this. The green line. Now this is slanted, right? This green line, if I extend it backwards, it will make some angle theta with the x-axis. Do we understand this? The tan of this angle theta, tan theta, is known as the slope of this line. Do we understand this, bacha? The tan, tangent, tan, sine by cos, perpendicular by base, that is known as the slope of this line. Is this line having positive slope or negative slope? That is the next thing that you have to understand. A line can have positive slope, a line can have negative slope. How do we find out whether the slope is positive or the slope is negative? This line, does it have positive slope or does it have negative slope? Now, how do you find it out? You look at what is happening with x. Now, if I go, let us say, from this point A to B, from A to B, the value of x is increasing, yes or no? If I go from A to B, the value of x is increasing, yes or no? What is happening to the value of y? What is happening to the value of x here, let us say, is x1, and the value of x here is x2. So when I go from A to B, x is increasing. What is happening to the value of y? Y is also increasing. Yes or no? Such lines are called as line with positive slope. Such lines are known as lines with positive slope. Do we understand this? The next thing that you have to understand is, how do I find the slope of this line? How do I find the slope of this line? How do I find the slope of this line? The slope of this line is constant. So I can find it between any 2 points. So I find out the value of this line. This will be y2 minus y1, yes or no? This is y1, this is y2. So this thing becomes y2 minus y1, yes or no? This thing becomes x2 minus x1, yes or no? So my slope tan theta, this is my perpendicular and this is my base. Perpendicular divided by base, yes or no? So I can write this tan theta as y2 minus y1 divided by x2 minus x1. This is the line with positive slope, and the slope is y2 minus y1. y2 is more than y1, x2 is more than x1, tan theta is positive, tan theta is positive, slope is positive. Do we understand this? Okay, I'll give you 1 minute to note it down. One more type of line is left. If I draw it here, it will become very bad. So I'm going to draw one more diagram for that one last line. So one last line, I will draw one more graph. Have you taken it? Have you noted it? Everything? Yes? Shall we move ahead? So we move on to the last type of line. I have seen a line which is flat, slope is 0. I have seen a line which is vertical, slope is infinite. I have seen a line which has got a positive slope. What is left? What is left? A line with a negative slope. And how does a line with a negative slope look like? A line with a negative slope looks like this. This line also makes an angle with the x-axis, but this angle is like this. Do we understand this? If I go from A to B, if I go from A to B, here it is x1, here it is x2. If I go from A to B, the value of x increases. But see beta, what happens to the value of y? What happens with the value of y? The value of y decreases. Such lines are known as lines with negative slope. Do we understand this? If I find the slope of this line beta, tan theta, it will be again equal to y2 minus y1, but y2 is less than y1, so it will be negative. So instead of writing it like this, I will write it as y1 minus y2 divided by x2 minus x1, and I will put a negative sign. Do we understand this? It is negative, I know it, but I will write it like this. This is the line with negative slope. So you must understand what is the line with positive slope, what is a line with negative slope, what is a line with zero slope, and what is a line with infinite slope, and how to find out the slope of the line. Do we understand this? Okay, then that takes us to the first graph that we have to understand. And the first graph that we have to understand is known as position time graph. This is the actual name of that graph, position time graph. But some people in some books will call it displacement time graph. Position time graph or displacement time graph. So in this graph, what happens? your position is plotted on y-axis and your time is plotted on the x-axis. And therefore, this graph is known as your position time graph. Do we understand this? Position time graph. Now, if I have to draw this position time graph, how will I draw this? Let me try to draw it. Again, I struggle to draw this. What is happening here? Okay, finally I succeed. Position of the particle, if I call it R, you can also call it X, you can call it Y, you can call it Z. It will be plotted like this. Position will be plotted on y-axis and time will be plotted on x-axis. Okay, now we can have different types of graphs here. The first graph that I can draw, now whenever we understand this position time graph, there are certain points that you must remember. The first point that you must remember is, let me write it here because there is no space here. The first point that you got to remember about this position time graph is the slope of RT means position time graph, will give us the velocity of the particle. Do we understand this? Slope of position time graph will give the velocity of the particle. If the slope of this graph is positive, that means the velocity is positive. If the slope of this graph is negative, that means the velocity is negative. If the slope of this graph is 0, that will mean the velocity of the particle is 0. Do we understand this? Now, when I say velocity of the particle is positive or negative, it means that we are talking about the direction. If the velocity is positive, it may be moving along positive x direction. If the velocity is negative, it may be moving along negative x direction. Remember, positive and negative only refers to the direction. Do we understand this? So this velocity can be positive, this velocity can be negative, this velocity can also turn out to be 0. Is it okay to everyone? Do we understand this position time graph? Okay. The second thing that you must remember is sometimes, just to confuse you, instead of drawing the position time graph, they can draw distance time graph. LT. Remember, I've used L for distance. So if you don't understand the symbols, you can write distance. The slope of distance time graph will give us what? The slope of position time graph gives us velocity. What does the slope of distance time graph give us? Tell me. I'm waiting, beta. The slope of position time graph gives me velocity. What does the slope of distance time graph will give me? Anyone? There are no right answers, there are no wrong answers. But I must know, what do you think? What does the slope of distance time graph give us? The class that I can see, can anyone tell me? The class that I can't see, can anyone tell me? Yes, beta. We've only read three things up till now: distance, displacement, speed, velocity, and acceleration. What does the slope of distance time graph give us?
Acceleration.
No, it gives us speed. If one gives us velocity, the other one gives us speed. Okay, so the slope of distance time graph gives us speed. Now, if you remember, speed cannot be negative. So for this graph, it will either have a positive slope or it will have a zero slope. So please note it down. I don't think you are noting things down. So please note them down. Note them down. Slope of position time graph. If you don't understand the meaning of symbols, please write their full meaning. R standing for position or displacement. Write everything. You don't have to write it in English. You can write it in any language that you understand. The slope of position time graph gives us velocity. The slope of distance time graph gives us speed. Have you noted it down? Okay. So now, once we know this, we can now understand the different types of position time graph. What is the first type of graph? The first type of graph is like this. Position is plotted on the y-axis. Time is plotted on the x-axis, and you can see this is a line which is parallel to x-axis. The slope of this graph m is 0. Slope of this graph is 0. Slope of position time graph gives us what? What the slope of position time graph gives us? Slope of this graph is 0. What does the slope of velocity time graph gives us? What does the slope of velocity time graph give us? What does the slope of position time graph give us, beta?
Zero, sir.
What does the slope of position time graph tell us, beta? What does it give us? Are you noting down anything in your notebooks or not? What does the slope of position time graph tell us? Give us. What is the quantity that we get from the slope of position time graph? Don't know? Okay. Can anyone read this out? The thing that I've written in red. Please, someone read it out. Can someone read it out for me? Please read it out, beta.
The slope of position time graph gives velocity. The slope of distance time graph gives us speed.
Okay, so what did I ask just now? I just showed it to you. I just asked you to write. Have you written this in your books or not?
Yes, sir, we wrote it.
And then if I ask you the same thing after 2 minutes, everyone is looking at the skies. I don't know how you're going to clear NEET. I'm really having doubts. I'm really having doubts. If I tell you something 2 minutes, not even 2 minutes, 1 minute before, and I ask you after 1 minute, you are all lost. I don't know how you're going to clear NEET. I'm really very shocked today. Loss of words. Anyways, may God help you. So, what does the slope of position time graph give us? Let's be more active. What does the slope of position time graph give us, beta?
Velocity.
Okay. Pakka na?
Pakka, sir.
Okay. Here the slope is 0. The line is parallel to x-axis. So the velocity is 0. And that is why this is written as velocity 0. Velocity is 0. The particle does not move. So this particle will be particle at rest. So if you have the position time graph in this way, parallel to x-axis, that graph represents motion at rest, or you can say the body is at rest, it does not go anywhere. Do we understand this? Please note this down, beta. I'm having serious thought whether you are noting it down or not. I'm really having serious thought, because if I ask you after 2 minutes and you can't tell me, it is a big shock that I can't seem to handle properly. Anyways, let us move ahead. I hope it was just a slip of your what should I say, concentration maybe. I guess that you knew what was that. Okay, that takes us to the second graph. This second graph is a graph that has how much slope? Oh, again, I'm asking you a question and I'm expecting an answer. This graph is parallel to y-axis, as you can see. The slope of this graph is infinite. The slope is infinite. That means the velocity will be infinite, because the slope of velocity time graph, the slope of position time graph gives me velocity. Velocity cannot be infinite. Therefore, this graph is not possible. Do we understand this better? Here, time, if we look at this graph, time is same, but the position is changing. How is that possible? Without any changing time, how can position change? Therefore, this graph is not possible. Do we understand this? Please note it down. Done. Then I will draw the third graph. On x-axis, I have plotted t. On y-axis, I have plotted position. Let me call it as y. And I draw the graph like this. And I draw the graph like this. If I draw the graph like this, the slope of this graph, what can you say about the slope of this graph? Slope of the blue graph? The slope is constant. It's a straight line. Slope is constant. What else you can say about the slope of this graph? Slope is positive, yes or no? Do we see that it has a positive slope? If the slope is constant, that means velocity is constant. Do we understand this? If the velocity is constant, that means what we can say about acceleration of the particle. If the velocity is constant,
0, sir.
well done, sir. So we remember things. Good. So you can write acceleration as 0. Slope is positive, so I can also say velocity is positive. Do we all understand these things from this graph? Yes or no, my dear friends? Good. I got a bit shocked by you not telling me the velocity, slope of velocity time graph, position time graph. But now I'm okay. I think we are back in business. So this was the blue thing. Today only I was giving the example of you guys to that JEE students. I told them that NEET students are able to do problems and you are not able to do this. And today only you said this, and I got my hopes were shattered. Anyways, let us now draw this graph, and this is the green version of this graph. Now let us talk about the green version. This is, let us say, graph number 1. So this is what we know about graph number 1. Let us now talk about graph number 2. I've drawn both of them in the same thing so that we can just understand them like this. What we can say about the slope of the second graph? It is a straight line, so slope is constant, yes or no?
Yes, sir.
Slope is positive or negative?
Negative.
Slope is negative. Since the slope is constant, velocity is constant, yes or no?
Yes, sir.
Therefore, acceleration is 0. What about velocity? Is it positive or negative?
Negative, sir.
It is negative. So the slope of this graph will give us velocity. If it is positive, it is positive velocity. If it is negative, it is negative velocity. Okay. If the graph is not a straight line, it will be a curve, and that will represent acceleration. If this graph is curved, it will mean that the body is accelerated. So you can write it as a note. What note you will write it? If the position time graph is a curve, then particle is accelerating. Do we understand it? These things about this graph is happening today. I'll give you 1 minute to note this down. If you note it down, let me know. Everyone, what happened to the other class? Are we there, beta?
Completed, sir.
Okay, sir. Let me now start with a question. And I guess my students will be able to give me the answer. Question number 1. Which of the following graphs represent uniform motion? When I say uniform motion, I mean motion with uniform velocity. Yes. Which of the following graphs represent motion with uniform velocity?
Option A, sir.
Option A, sir. That is correct, sir. Say hi. यहाँ पे आगे.
Hi.
Hello. So option A, because this graph is a straight line. Position time graph is a straight line, velocity is constant. This graph is also a straight line, but we don't call it uniform motion because this represents a particle at rest. Do we understand this? Okay. Things are looking good now. Well done. Let me ask you this question now. I hope we have done with this, everyone. And this is the next question. I have to put it into different parts because the question is segregated. Let me put all the parts together and ask you the answer. Yes, here comes the question. From the following displacement time graph, sometimes they call it displacement time graph, that is not the correct nomenclature. From the following displacement time graph, find out the velocity of the moving body. Yes, bacha, what is the answer? Option 1.
Option 3, sir.
Huh? Not option 1.
Option C or A.
Okay. As soon as you see displacement time graph and someone asks you velocity, you will find the tan of this angle. So you will find tan of 30 degree. That will be equal to velocity. Tan of 30 degrees 1 by root 3. So you'll say the answer is 1 by root 3. But that is not the answer.
Option C.
Remember, when I found out the slope on this side y-axis, it was displacement, and on the x-axis, it was time. They have reversed the order. So you have to find the angle with the time axis. Do we understand this? Angle with the time axis, not with the displacement axis. Angle with the time axis would be 60 degrees. So the correct answer is tan of
60. Root 3, sir. Option
tan
C.
of 60, which is root 3. So my dear friends, this is not the correct answer. This is the correct answer. I hope you understand this.
Yes, sir.
These are the type of questions, and they have come multiple times in multiple exams. And if you're lucky, you will have the same question coming in your exam. So here is a chance for you to crack a question of this year, next year, or next to next year, whatever. The displacement time graph for two particles A and B are straight lines, inclined at an angle of 30 degrees and 60 degrees with the time axis. With the time axis. What are the ratios of velocity V and VB?
Option D, sir.
Option D. And that is correct. Well done. Question number 3. How did we get this? We had to find out the ratio of VA and VB. So how do we find out the ratio of VA? VA will be tan of the first angle, tan of 30 degrees. VB will be tan of 60 degrees. I have to find out VA by VB. Tan of 30 is 1 by root 3 divided by tan of 60 is root 3. 1 by root 3 divided by root 3 is 1 by 3. So your answer is 1 by 3. Well done. Do we understand how we have to supposed to do this?
Yes, sir.
If you do it carefully enough, you should be able to solve any question that comes on velocity. And remember, when this position time graph comes, they will only ask you what is the velocity. If you can tell them, well, you will score +4. Here comes the next question, and let us see if you can give me the answer for this one. Question number 4, I am calling it. The diagram shows, again, they use the same term, displacement time, which should be position time. Displacement time graph for a particle moving in a straight line, the average velocity. Average velocity for the interval 0 to 5. You can look at the interval 0. This is 0. This is 5. What is the average velocity from 0 to 5? And I patiently, with a lot of patience, await your answers.
Option C, sir.
Option C, sir. That is correct, sir. Well done, sir. You have to find out the average velocity. There are two ways in which you can do this, my dear friends. Either you can find it out by total displacement divided by total time. At time t is equal to 0, displacement of the position is 0. At time t is equal to 5, the displacement of the position is minus 10. So you can write average velocity as total displacement divided by total time, my dear friends. Total displacement is minus 10, total time is 2, right? Total time is 5. My answer will be minus 2 meter per second square. Do we understand this? Yes or no? Or you can also do it in this way. You can find the slope of this line. You can find the slope of this line, theta. Do we understand this? Even if you find the slope of this line, it will be 10 divided by 5. It is negative because as time is going up, position is coming down. Do we understand this? So it will be a graph of negative slope. And you have the answer of velocity as negative. Well done, 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 well done. And here comes the next one. My faith in you have woken up again. I hope you don't disappoint. Shock me. It was not disappointment, it was shock. This one comes for you, my dear friends. I've forgotten the number. I'm just writing awkward numbers. Let me call this question number 6. Figure show the displacement, again displacement time, graph for a body. What is the ratio of speed in the first second to that in the next 2 seconds? Yes, my dear friends, do we have an answer? Yes or no? No, yes.
Option D, sir.
Option D is correct, sir. Well done, sir. To find out the speed or the magnitude of velocity in the first second, we have to find the slope of this graph. Graph number 1, yes or no? Perpendicular to slope of graph number 1. Slope of graph number 1 is 30 divided by 1. So that is 30. Then I have to find slope of graph number 2. That is 30 divided by 2. And that is 15. Yes or no? I can find the ratio. That is 2:1. Do we understand this? Okay. Okay, we now move on to the next question, and this is the next one. Which of the following cannot be a distance time graph? Which of the following cannot be a distance time graph? Yes, my dear friends, what do you think? And the answer is yes. I can't hear you. Option B is not possible. Why it is not possible? Because if a body is covering distance, distance covered by a body cannot decrease with time. If a body is traveling, if a body is traveling, it always covers positive distance. Distance does not decrease. Do we understand this? Distance covered by a body always increases. Distance cannot be negative and distance cannot decrease. Do we understand this? Okay. So here we are doing graphs. We will continue with this graphs in the next class, and in the next class probably we will be ending up with this graphs and moving into the next chapter, which is motion in 2 dimensions. Do we understand this? So we'll start with motion in 2 dimensions after we finish your graphs in the next class. Do you have that sheet that I've given you? Are you practicing questions from that sheet? There are a lot of questions I can see. This question was from the sheet only. There are a lot of questions on graph on this sheet. Beta, if you can do them, I guarantee you on a stamp paper that the same question you will see in your examination hall. So please do those questions from the sheet. I'll see you in the next class. Take care and have a very nice day. Wishing you all the best for the festivals. Are you going to home?
No, sir.
Don't go because your festivals are in the hostels and we have to celebrate festivals there only. Wish them.
Bye. Happy Diwali. Same to you.
Okay, so happy Diwali to all of you. Take care
Same to you, sir.
and God bless all of you. Bye bye.
Bye, sir. Bye.
Done?